students, today we are going to learn Newton's second law of motion. But before we begin, let us understand what is momentum. Children, if you ask your friend to drop two balls, one rubber ball and one scissors ball from a certain height, and you stand down to catch it, which will be easier for you to catch? Of course, rubber ball. Why is it so? That is because the force exerted by the rubber ball will be less on your hands than that of scissors ball. So force depends on mass of the object. Now in the second case, if you ask your friend to throw a rubber ball once very slowly and second time in a very high velocity, so which will be easier for you to catch? Of course, the ball which is slow. So why? Because the ball which is slow will exert less force on your hands than the fast moving ball. That means the force also depends on the velocity of the object. Thus, force depends on mass as well as velocity. And this property of any object which depends on mass as well as velocity is called as momentum. And this is defined as the product of mass and velocity. It is represented by letter P. So P is equal to mv. Children, we have learned that velocity is a vector quantity. So momentum is also vector quantity. Now let's see the units of momentum. SI unit of momentum will be, as mass is in kg, it will be kg. Velocity is expressed as meter per second. So SI unit of momentum is kg meter per second. Now let's see what will be the CGS unit. Mass in CGS is expressed in grams, whereas velocity is expressed in centimeter per second. So CGS units of momentum will be gram centimeter per second. Is that clear to you? Now we will see what is Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum is directly proportional to the applied force and takes place in the direction of the force. Now let us derive mathematical expression for Newton's second law of motion. For that, let us consider a body of mass m moving with initial velocity u. In time t, it attains final velocity, say v. As the initial velocity is u, what will be the initial momentum? Momentum is product of mass and velocity. So mass is m and velocity is u. So initial momentum is mu. As final velocity is v, what will be the final momentum? Final momentum is equal to mv. Therefore, change in momentum is equal to final momentum minus initial momentum. So it is mv minus mu. Okay. Now, therefore, rate of change of momentum. Change in momentum. Children, I have already told you whenever word rate comes, it is divided by 10. So, mv minus mu divided by 10. That is change in momentum divided by 10. That is what is rate of change of momentum. Why have we taken rate of change of momentum? Because Newton's second law of motion states that rate of change of momentum is directly proportional to the force applied. Therefore, we have taken rate of change of momentum. Now, this rate of change of momentum is directly proportional to the force applied. So, mv minus mu divided by t is directly proportional to the force applied. So, this m is common. v minus u divided by t directly proportional to f. Children, whenever we are removing proportionality sign, we insert equal to and proportionality constant. So, it becomes m v minus u upon t is equal to f into k, where k is constant of proportionality. And which is equal to 1. So, m v minus u upon t is equal to f into 1. Okay, let's continue here. So, m v minus u upon t is equal to f into 1, how much? F. Therefore, but we have already learned v minus u upon t is what? Is acceleration. So, let us substitute v minus u upon t as a. So, m into a is equal to f. Thus, we have derived that force is equal to mass into acceleration. Okay, is that clear to you? So, whenever you are asked derive mathematical expression for Newton's second law of motion, this is what you have to derive. Is that clear to you? So, according to Newton's second law of motion, we have force is equal to mass into acceleration. Therefore, it is easier to push an empty cart than a heavier cart in the supermarket. Okay. Also, the athlete in the high jump event, athletes are provided with a cushion bed or a sand bed. This is to reduce the time of the athlete of jumping. This is what happens. Force is equal to u upon t. See, force is inversely proportional to the time. If the time is increased, then force will reduce. So, whenever the sand bed is provided, time required to reach the ground is increased. So, the force is decreased. So, to avoid the injury to the athletes are provided with a sand bed or cushion bed during the high jump event. Okay. Now let's understand units of force. The unit of force in SI system is Newton. In SI system and in CG system it is Dyne. If you are told to define 1 Newton force, how will you define? First of all, we have to write the formula for it. Force is equal to mass into acceleration. Then write units of each. That is, force, unit of force is Newton, unit of mass is kg, and unit of acceleration is meter per second square. Now we are told to define 1 Newton force. So write here 1. And so this also will be 1, 1. So how will you define 1 Newton force based on this formula and these units? 1 Newton is defined as the force necessary to, what is this? To cause, this is A is acceleration. So we have to write acceleration. How much acceleration it causes? 1 meter per second square. Acceleration of 1 meter per second square in the object of, what is mass of the object? M is mass. So we have to write mass of the object of mass 1 kg. Okay. So that's how we define 1 Newton force. Similarly, we can define 1 Dyne force in CGS system. Now, here write units in Dyne, CGS. So what will be units in CGS? Here it will be Dyne. Here mass is in grams. Acceleration is centimeter per second square. Same words we have to use, only little changes we have to make. The force, write as it is, necessary to cause acceleration of 1. Now it is Dyne, it is CGS, so write centimeter per second square. Centimeter per second square in the object of mass 1. Now you have to write gram. Okay, this is 1 Dyne force. Is that clear to you? I hope you will be able to define it yourself without cramming it by heart. So mathematically, 1 Newton force can be expressed as 1 Newton is equal to mass into acceleration. So mass is expressed as 1 kg and acceleration is expressed as 1 meter per second square. Okay. Whereas 1 Dyne force can be expressed mathematically as 1 Dyne is equal to 1 gram into 1 centimeter per second square. I hope it's clear to you. Now let us start numerical based on Newton's second law of motion. Now we are going to solve question number 7b given on page number 17 of your science textbook. An object of mass 16 kg is moving with acceleration of 3 meter per second square. Calculate applied force. If same force is applied on an object of mass 24 kg, how much will be the acceleration? Solution. First of all, let us write what is given. An object of mass 16 kg. What is 16 kg? M. Mass is equal to 16 kg. Is moving with an acceleration of 3 meter per second square. So what is 3 meter per second square? Acceleration A. 3 meter per second square. Calculate the applied force. So force we have to find out. We will do part wise. So according to Newton's second law of motion, force is equal to mass into acceleration. So what is mass? 16 and acceleration 3. 16 3 is 48. What is unit of force? Newton. So force is 48 Newton. Now we will solve next part of it. If same force is applied, so we will take F as 48. F is equal to 48 Newton, which we have got just now. If same force applied on an object of mass 24 kg, mass is 24 kg, how much will be the acceleration? Acceleration is to be found out. So question mark. Again, according to law of motion, Force is equal to mass into acceleration. So let us substitute. Mass is 24. Force is 48 Newton and acceleration is to be found out. So A is equal to, let us take this 24 this side. Here it is multiply, that side it will go, it becomes division. 48 divided by 24. 24 ones are 24 twos are 48. So A is 2. So what is unit of acceleration we have learned? Meter per second square. So we got acceleration as 2 meter per second square and force as 48 newtons. Is that clear to you? I hope you have understood. Thank you. So dear students, if you like my teaching, do hit the like button. And please do not forget to share and subscribe to my channel. For more updates, please hit the bell icon. Thank you.